KC, hope you're doing well today. This is Coach Johnson. I wanted to give you a little bit of a sneak preview. Just a couple things. Have you ever seen people on Facebook who are or Twitter, or Instagram that constantly talk about their kids or whatever? You probably unfollow them. You may be unfollow me right now, and that's A-okay by me. But I just want to brag on my daughter. Just wanted to give a couple of pictures here of her from the hospital. Charlie, little shout out, by the way. Little shout out to Charlie. Retweeted that. There's my mom with Emmy. And then that's us going home right here. Oh, man, she's such a little thing. I'm so proud of her. Love her to death. But just wanted to throw a little shout out there. Hey, today we're going to just have just a little bit of an introduction. First off, I appreciate the fact that you've been diligent. Those of you who have watched the podcast have been diligent. Thank you so much. I know that, again, this has not been easy for you, but I appreciate the fact that you understand and that you've been willing to go on podcasts, and then you've been willing to go online with me at night to ask questions and go from there. Also note that Monday and Tuesday of this following or the next week, there will be that makeup. So if you have any questions or if you're planning on showing up, I'd appreciate just an email just letting me know what's going on. As we go through these next few questions, understand that these questions are just setting us up for what we'll do in the future. This one, different than the other ones, you do not need mastery of this. This is something that you just need to just kind of touch base on. We'll have more information and more details to come next week. Okay. Also note that Monday I'm planning on having a Q&A session. So any questions that you have, if you have any other questions, please make sure you see me, touch base with me. We'll go from there. Okay. All right. Without further ado, we're going to get started on this. We're only going to do about 3 questions and make sure we kind of give an introduction on it, and then we'll be underway. This will be our last podcast for the week. Okay. Also note that this is getting closer and closer. We only have 2 more lessons after this until we are completely done. Okay. I'm hoping that this bamboo tablet doesn't give out on me, but if it does, then we will go from there. Now, as we look at this, there are 2 differences between a hyperbola and an ellipse. Now, remember that with an ellipse, if we were to take a cone, right, and we were to put 2 cones together, we kind of showed this on podcast 1, and we went sideways, we have what was called an ellipse. However, if we came, let's say we had 2 cones stacked on top of itself, right, 2 ice cream cones there, and I cut it this way, what would happen is you would get a shape that looks like this, and you kind of see what I'm saying down below. So a couple things that we need to note with this that are very important. First off, it's different with A and B. Normally with A and B, we change it based upon the major axis, but in this case, the A will always be underneath the first value. Okay, the A is always underneath the first value, whereas the B will always be underneath the B value. Now, a little different than what we did before, if the X comes first, okay, and again, a couple of differences, let me make sure. So the first one, A is always underneath the first one. It doesn't necessarily mean that it's the greater of the 2, okay? It's a little different from the hyperbola, from the ellipse. Also note that with the negative sign, that is the only difference between a hyperbola and an ellipse when you look at that equation. So if I change that to a positive value, we would know that if that was positive, either both on bottom or on top, we know that in that case we would have a hyperbola rather than an ellipse value. Okay. Now, as we keep going, you'll notice that in an example like this, we have also 2 focuses, or we call them foci, that are inside of the hyperbolas, okay? Which, again, really is just 2 parabolas. We have a center, okay? We have a center, and we have what are called vertices, where both parabolas, both on top, bottom, or left or right, are graphed. Now, how do I know whether it goes up, down, or left or right? Well, it all is dependent upon which one is first. For instance, if the X is first, it will go left and right. Whereas if the Y is first, then it will go up and down. Okay? Now to help us out with this, let's do this. Let's graph one here. And let's see if we can get this going. By the way, I'm going to come to a little bit later, okay? All right, I'm going to come to a little bit later. In fact, I'll finish off with that at the end. So in this example, we have the a squared being set equal to, a squared is equal to 1, whereas the b squared is equal to 4. That's different, right? Normally in the ellipse, the major axis would have to do with the a, which would be 4. If this was plus, you would be exactly right. But with that subtraction, this tells me that, oh yes, this is a hyperbola of some kind. So because of that, our center is going to be at 0, 0, because there is no h and k. Notice on the one on number 11, our center for this one would be at 1, comma, negative 2. So that's where we would start this one. But because there's no transformation, the center is at 0, 0. So we start there. Now, since this y is coming first, we're assuming that the hyperbola will go up or down in some form or fashion, okay? So that's kind of what we're looking at. So in order to kind of help us out with this, we're going to see where this hyperbola starts. So we've got to create our magic box, okay? All right, so our box is created by, because the a squared is equal to 1, we know a is 1 because we square root of 1, we get 1. We square root this side, b will be equal to 2. So what this tells me is that this is going to go up 1 and down 1, okay? Up 1, down 1, very similar to the ellipse where I square root it and go from there. B is going to go left 2 and right 2 because the 2 is, or the 4 is underneath the x. So what we have now is we have our box right here. So instead of an ellipse, now we've got a box that goes just like this. Now, in this example, we have what are called with asymptotes from corners to corner that goes through the center and goes all the way to infinity and beyond. So it should kind of look something like this. Now, I can either graph this to the right and left or up and down. Because the y is first, we assume that it will be up or down. So I go to my vertice, and this one is one you don't have to be completely accurate on because it stays inside of my asymptotes. But all I need to know is that it would be a hyperbola or two parabolas, one going up and also one going in the downward direction. My vertices are where they come in contact, or where, just like a parabola, where it's the lowest or highest point. So my vertices would be at 1, 0 and -1, 0. Now here's where the rubber meets the road. Remember beforehand, we've talked about like foci, right? We've talked about that before. In order to find my foci again, it's very similar to what we did with the parabola. With this, we do c squared equals a squared plus b squared, where a squared is 4, b squared is 1. We square root both sides, to where c is equal to the square root of 5. What does that mean? Well, that means that from my center, remember it's got to go up and down because it's got to be inside of my parabolas. There's two of them though, right? A little different because in a parabola, beforehand, there's only one graph, whereas this one, there's two. So in order to kind of figure it out, we start at the center, and we're going to go up and down. So we're not going to go left or right, just up and down. So the foci, the only thing that would change, x's wouldn't change, but the y's would. We would just add square root of 5 and subtract square root of 5 to where my foci would be there. My c you've already gotten. My center and my vertices are right there, okay? Now, last but not least, they have what is called, they want to find maybe like the asymptotes, the equation of that. And so you'll notice this. Don't look at the b and a. I'm going to give you a little easier way. But we know that it'll be y equals k plus or minus, and it's that way either way. Okay, so this is all the time. I'm going to look at this rise over run here in a second, and then x minus h. Okay. All right. So the center is 0, 0. So the k is 0, h is 0. So it's really y equals plus or minus the rise over run times x. Okay. So really, it's just, again, whatever the rise and run is. So whatever is the y, in this case, it's the 1. Okay, remember, take the square root. So here's a and here's b. Whatever one has y underneath, remember the rise always comes first, so the y always comes first. All you need to do is find what the x is, or the y is over the x. So it'd be, in this case, 1 over 2. So square, because we're just finding the a, not a squared. So it'd be 1 over 2. So it'd be y equals plus or minus 1 over 2x would end up being what my asymptotes are. So if I was graphing these dotted lines and I wanted it really specific, or I wanted the equation, I would do the y equals plus or minus 1/2 over x. Okay? Now let's go to this other one, and then I'll kind of hit on one more. If I do, that's great. If I don't, that's fine too. Okay? Because I'm going to hit on this a little bit harder next week, but I want to make sure you've at least started on it. So we've got a center at 1, -2. Okay? Remember, A is always the first one. Doesn't have to be the greatest. In this case, it is, but doesn't have to. We square root that to get 2, and B is 1. Okay? Now, since the 2 is underneath the x, we know we're going to go right 2 and left 2 from my center. Okay? And since the y has the 1 underneath it, we're going to go up 1, down 1, and we create our magic box. Okay? Now, remember that with this one, from corner to corner, we'll have our asymptotes. Does not have to be perfect. Doesn't have to be perfect. But we know we have our box there, okay? And our asymptotes. Since the x is first, we know that it's not going to be up or down. It's going to be left or right. So we're going to keep this parabola inside of the asymptote. Okay, so we're coming here, boom. And no, this is awful as far as trying to do it on this. But so you see where that is. There it is. And so you can kind of count -1, -2. So our vertices is -1, -2. And what is that? 3, -2. Okay, so there's our vertices. The center, we already said, was 1, -2. And since the foci has to be inside of the parabolas, both parabolas with a hyperbola there, we know the foci is going to have the same y. Okay, so in this example, the y's will stay the same because, again, we're not moving up and down, we're just moving left or right because of where the graph is. So this is going to be -2, keep that the same. And all we're doing is we're going to change the y here. So in order to find the distance from the center, we're going to say c squared equals a squared, which is 4, plus b squared, which is 1, square root, to get c equals square root of 5. So really what we have is from the center, 1 plus square root of 5, because that's 1, right? So we add it, and 1 minus square root of 5. To where when we get it, it will end up being somewhere in that vicinity there, okay? And again, that foci is equal distance. We talked about that. We're talking equal distance, and it just helps us when graphing, and it helps us when we're finding out the characteristics of the graph, okay? All right, so one other thing, I want to make sure I kind of go back, make sure one more thing. And as I'm saying that, all right, I think that's it regarding that. One other thing that I wanted to mention was the equation for the asymptote. So it should be y equals k plus or minus rise over run times x minus h. Okay, remember that h and k is the center. So h would be 1, k would be -2. So 1 is h, k is -2. The rise over run is basically, you could kind of look at it here. If you can't see it, you could also say that it's also 1 over 2 because the y always comes first, okay? And then the x. So it'd be 1 over 2. So it should be -2 plus or minus 1 over 2 times x minus 1. And if you really want to be specific, at which I would like for you to go just one step further, and that's distribute 1/2 to get 1/2 x. Distribute 1/2 to -1 to get -1/2. So we'll have two equations where we have -2 plus, -2 minus. When we minus, make sure we take it to both of them, okay? So -2 plus 1/2 would be -1.5 or -3/2. And so this one would be -1/2 x minus 3/2. So that's the first asymptote. The second one would be -2.5. So we could say -5/2. we have 1/2 x minus 5/2. And that's the second one. So when we solve for those, just giving you an idea, that's how we would do it if the center was a little bit different, if we had like an h comma k like we've done before. Again, remember, difference between ellipse is really that minus in the middle. And remember that the a always is associated to the first value when going forward, okay? Now, if you're really feeling like, man, I really want to go after one, or coach, please, I love math, I want to do it some over the weekend, what you might want to do is maybe try this one out, where we put the x's together, right? You've done this before on the ellipse side. Subtract the 18. Put the y's together. So we, again, since this is the negative y squared, we'll put that one second. Okay, so we got that there. We're going to pull out a negative here. So we got, actually, we'll pull out a 9. So we'll pull out a 9. Should be 4 there because I took out a 9 there, so 4x. Take out a negative to where it's y squared. Plus 6y equals negative 18. All right, this right here would be half and square it, so half 4 and square it would be positive 4. So we add 36 to make sure it's even. If I half 6 and square it, I get plus 9. Really, it's negative 9 because it's negative 9 on the outside, so I subtract 9. So really, this is negative 18 plus 36, which is 18, minus 9 would be 9. So this is equal to 9. Perfect square, y plus 3 squared. When I factor this, would be y plus 3, y plus 3. This one would be 9 times x minus 2, or x minus 2 squared. So what we have now, if I were to divide by 9 to get that 1 there, got to do it to all of them. This would be x minus 2 squared, because these 9 would cancel, over 1, minus y plus 3 squared over 9 equals 1. So my center would be at 2 comma negative 3. This would go left and right, just like so, because the x is first. The a squared would be equal to 1, b squared would be equal to 9. And then you could be able to find it just like we did on the previous one. We just do it below. So the big thing is not necessarily, it's just getting to this point. Once I get to this point, then I could do it the same way that I've been doing there, okay? And I know this one was a shorter one for you. We'll go over this a little bit more in depth next week. On Monday, we're gonna hit up some questions. So if you have questions on 9-1A all the way to 9-3A, 9-3A, then please make sure you contact me there, all right? Hey, care about y'all. Hope you all have a great weekend, and we'll hit it up next week. We'll go from there. Also, make sure all Six Flags stuff is taken care of by today. Make sure you get that to Miss Lawrence or Miss Allen. Thank you so much. Have a great day. Bye.